In ElectroBIM, we have the project options, and this is where you control all the various settings you have for ElectroBIM in your project. And there's a lot of options, and we will take a look at all of these. When you make these changes, you then have to figure out how to get these changes to other projects, because when you make a change to all of this, you're going to get this set up once. You want to have it all configured for how your company likes to work, and you don't want to have to make these changes in every project. There's really two ways you can handle that. One, you can open up your template file, run this command, the project options command in your template file, and make the changes there. And then that template will have the settings in it, and then all projects based upon that template will have your settings. The other option is to use the customization, export, and import commands. So you would find the project, you would get everything set up properly there. Then you can run the export command. When you run this, you have choices for what you are actually exporting and where you're exporting it to. So you give it a file location that you're going to export, and then choose what you want to export, the various option settings, and then also some wire sizing and transformer settings. And you can save that to a file. And then in future projects, you run the customization import command. So you take that file that you've exported it, and then you import it into other projects. So that's just two different ways you can do the template, or you can do the export import. One benefit to the export import is that you can then pull that into projects that have already started. Otherwise, if you use the template, you have to make sure to start with that template. And then once the project started, there's no way to update it. So the export import gets around that limitation with the templates. So if you have a template, you can set that up. There's probably a place for everyone to be using export import as well. Let's take a look at the voltage drop options. The first options in voltage drop are related to the voltage drop limits and automatic upsize. So we have the option for feeders and branch circuits separately to upsize automatically for voltage drop. And so if we are upsizing, then we have the additional options for the multiplier for how big we'll let the feeder or branch circuit get before we go look for something else to upsize. And then we have the limits that we are upsizing to. Again, separate out between feeders and branch circuits. If we are not upsizing, or if these maximum values don't let us make something big enough because we have some situation where the voltage drop has gone, just kind of gone out of control. If it exceeds these values, we'll also flag it in the schedule, and we have parameters for that. For complete details on how all of our voltage drop works, again, we have another training video on that. Go watch that training video for more in-depth discussion of how all of these options work and how to use them. But this is where you can set them for your project. And these are going to be settings for the voltage drop for the entire project. Then the next section are, again, some refinements on what we're doing in the voltage drop calculation. The first one is how we're handling our transformer voltage drop. We have a knowledge base article on that. And this is essentially modeling what you're doing with the taps on your transformers. There's three options for what you're doing with it. You can include the voltage drop through the transformer, you can ignore the voltage drop through the transformer, or you can reset the voltage drop to 0. So if you include the voltage drop through the transformer, you end up with really high voltage drop values, because there's actually a fair bit of voltage drop through a transformer. So this actually tends not to work if you have any of those limits set. So you can include it, just be aware that we've got the picture here showing how that calculation ends up working, and you end up with fairly high voltage drops. The next option is to ignore the transformer, and then the other option is to reset the voltage drop. And these are both assuming that you're using the taps and you're making an adjustment to account for that voltage drop through the transformer, and essentially how aggressively you want the contractor in the field to make that adjustment. If you're ignoring the transformer, we'll set the transformer voltage drop to 0, but we will continue the voltage drop from the utility through it. So in this case, we have this 0.5% voltage drop upstream of the transformer. That's going to carry through to this panel downstream. And then the most aggressive is that you reset that voltage drop to 0. This is where you're cranking those taps up even more, so that we have that 0.5% voltage drop upstream of the transformer, but then downstream of it, we go back to 0% and start from there. So those are the three options we have for the voltage drop through a transformer. Then we have options for what the voltage drop load is based upon. We can either do it based upon the loads in the project or based upon 80% of the panel or breaker capacity separated out between feeders and branch circuits. So you have different options for how you want to do your voltage drop calculation, what load it's going to be based upon. And finally, for the voltage drop, the power factor is an input there. Revit has the power factor on its circuits, and so we will read that in and use it. If you're not setting those values or they've not been set well in your project, we have it where an option where you can fix it at 0.85. And again, for a complete demonstration of how all these features work, go take a look at the video on voltage drop calculations.